Hello friends, in this video we are going to discuss about the common base configuration of a bipolar junction transistor. In this case, take a NPN transistor. So in the figure you can see it is an NPN transistors and the emitter, collector and the base terminals are put here. So for making these transistors to operate in the common base operation, we have to connect RC resistor here at the collector terminal, and between the base and the collector we have to give a voltage source VCC in this fashion such that the positive polarity is connected to the collector and the negative polarity is connected to the base. This is our VCC voltage and this is the RC resistance. Similarly, if we connect RE resistor here, this is the emitter resistance. With this emitter resistance, we have to connect the voltage. This is our NPN transistor. So we have to connect a negative potential here and a positive potential with the base. So we have connected a positive potential with the base, negative, positive, and this voltage is called the VEE voltage. So we can say right now, so the current that will flow in the input circuit will be the IE current. So this is the IE current, and the voltage here will be the VBE potential, and similarly you can get here a potential that is VCB potential, and a collector current will be in the inward direction the collector. So this is the direction of current in the emitter terminal and the collector terminal. So if we look at the input parameters, then the input parameters will be the IE current and VBE voltage, and the output parameters will be the IC current and the VCB voltage. Now, if we want to find the input characteristics, then we have to plot, or you can say the input characteristics. We have to plot IE versus the VBE potential when the VCB voltage is fixed. Similarly, the output characteristics for the common base connection will be the IC versus VCB when the input current, that is the IE, is fixed. So let us see that the input characteristics. So for the input characteristics, if we write here the input characteristics, for the input characteristics, what we can plot, we have to plot I, E, that is the emitter current, input current, and the input voltage, that is the VBE voltage, keeping the output voltage constant, that is the VCB. So we can say that in this case of input characteristics, the emitter current will be a function of VBE and VB. So the curve will look like this. We'll get an exponential curve like this. Then we'll get an exponential curve like this. We'll also get an exponential curve like this for different value of VCB. For this case, the VCB value will be the suppose 10 volt. Here the VCB value suppose 5 volt, and here the VCB value suppose 1 volt. So as the VCB value increases, the curve shifts towards the left side, and it is similar to the forward bias junction voltage current characteristics, and sometimes this voltage is also called as the knee voltage of the input characteristics. Generally, it is the cut-in voltage of the material. So from these input characteristics, you can see that IE increases very rapidly for very small change of VB beyond a point, and from this CB configuration, you can find the input resistance of the characteristics. So if we find the input resistance from the input characteristics, it is Ri P, because it is a common base connection, and in this common base connection the value will be P dE divided by del of I. This is the value, the input resistance of the base common base node when the VCB voltage is fixed. This RIB is generally called the AC input resistance, and the AC input resistance is different in the lower and the upper portion of the curve. You can see here at this point the AC resistance is different and the R input resistance is different in this different portion of the curve. It depends on the operating point where the transistor to be operated. So this RIB has different values at different points on the curve. Now let us see what will be the output characteristics of a common base configuration BJT. So for the output characteristics, know that we have to plot the output current, that is the IC current, with the output voltage, that is the collector base voltage, keeping the input current fixed, and the input current is here the emitter current. So we can say that the IC current will be a function of VCB as well as the input current IE. Now if we plot the output characteristics, before plotting the output characteristics, let us denote that this is the origin and this part is the negative value of the B. So when the IE value will be 0, the curve will look like this. characteristics will look like this when the IE value will have a 0. When we increase the IE value, then we will get a curve like this. So let us assume now the IE value is 2 milliampere. Similarly, if we increase the IE value to 4 milliampere, then the curve will look like this. The IE is here 4 milliampere. So further, if we increase the value of IE 6 milliampere, then we will get it as 6 milliampere. So if we increase the IE further to 8 milliampere, then we'll get the IE current here as 8 milliampere. So we can see this is the output characteristics of a common base configuration where the IC value increases with the I current, and if we denote this region like this, denote this region, that is the zero origin, like this, then we can divide the graph in three regions. This region is called the saturation region, and this region is called the active region, and below here this shaded region, here, the output current is nearly equals to 0. That's why it is the cut off region. In this way we can find the three different regions, and in this saturation region we can see that the both emitter base and the collector base junction are forward bias. This means that the collector base voltage is that for the saturation, if I write, then we can say that the collector to base potential is less than 0 due to the forward bias in the NPN transistor, and a slight increase in the VCB. The slight increase will result a large increase in IC, and the IC is increasing exponentially with the VCB. Now, in the active region, we can see that the IC current nearly constant for the VCB value, and in the cutoff region, the IC value is nearly 0 because the junction are at reverse bias. From these output characteristics, we can find the output resistance like this. ROB can be defined as del of VCB divided by del of IC when the IE current is constant. And the output characteristic curves of common base transistors are almost linear and parallel to the voltage axis. And when the IE current is 0 in the saturation region, we can say in the cutoff region, we can also say that the IE current is 0. If the IE current is 0, then the IC current that will flow will be ICBO. So ICBO is the collector current when the emitter current is 0. So in this case, we can also define the DC current gain as alpha, and here alpha will be the output current IC divided by IE. This will be the DC current gain of the transistor in the common base connection. So this is all about the common base configuration of a bipolar junction transistor, where we can see that we have found the output resistance as well as the DC current gain. Thank you.